Good evening, everyone. Thank you for joining this online Science Café. For one more time, this is our last for the year 2021, and we are looking forward for the year 2022. So, as you most probably know, we started earlier this year, actually last January, the online Science Café. We used to host on Science Cafés here every Wednesday since our establishment, since to NTO8. Every Wednesday evening, we used to host a Science Café here at our premises of the planetarium. And after the pandemic, we have decided with our team last year to host a Science Café online. So we can gather more people, or we can gather people from around the world, different continents. So we wanted to unite the world in our way, to share knowledge and experience, and share observations, meet new people, and gain knowledge. Meet some other people, some other areas of science that we are not very experienced with, so therefore we held this year, including this one, 19 online science cafes. We don't hold them anymore twice a month. We hold them every last Tuesday of the month, so the third Tuesday of the month, actually. Not on the last, but we postponed this one to the last Tuesday of this month because of the busy schedule. So we try to deal with a wide range of subjects. We touch subjects like meteors and meteorites, pollution, care for the environment. We did a lot on astrophotography, a lot of space exploration, about science outreach and amateur astronomy. We celebrated together the World Space Week, Women in Space, which is a great subject. We even had the pride to have with us the CEO of the American Association of Variable Stars Observers, our friend Stella Kafka, our friend Jim Wiggins, and all important people that they are dealing with some of the most important projects in the world. We have them here in our company, and we are also proud that we hosted our Cypriot woman pioneer, Eleonora, the analog astronaut, the first Cypriot in the Analog Astronaut Training Center, and we are happy that she's in our team now. And many friends from Lebanon, cooperation, from England, from we had people from Iraq, from Syria, from Iran, from Canada. These are some. In the beginning we had from Australia, so we had people from all continents. So this is incredible. This is lovely to share with us their time and spend their time with us and share knowledge. Tonight, after this summarization of events, if I may say summarization, because if we go through each one individually, we're going to spend the whole Science Café like this. Tonight we also have special guests, and we have 5 speakers. Follow me. Each one will do approximately 10-12 minute speech. We have Ekaterini Demetriou, our space scientist. She's going to speak about space exploration. And she will be followed by our very good friend and member, Ara Mahdessian, who is also Katie's student here at the English school, and he represented Cyprus at the 14th International Olympiad on Astronomy and Astrophysics. He's going to share with us his experiences. Then we're going to have our friend from Lebanon, Maroun Habib. He's going to talk about astrophotography and Comet Leonard. Then we're going to have our friend from NASA JPL, Jim Wiggins, all the way from the United States, but now he moved temporarily to Spain. So he's going to talk about his observation of astronomical phenomena, and I can guess most probably about solar eclipse. I don't know, I don't want to predict, but I have this feeling. And then we're going to have our astrophysicist, Alexandr Prokofyev. He's going to talk on meteor showers in January. We have a peak on January 10th of K-Cancrids. So, guys, welcome again, and let's start with Katie.
Hi, everyone. So I'm going to speak to you about what I, as a space scientist, found really fascinating about 2021. And it's been some time, so I'll just ask Alexandra if I can share my screen. Cool, excellent. Right, so space science specials, space exploration specials in 2021, and a link to what is really, really going to be exciting in 2022. So my first slide, as you can see, is not SERI, it's Mars. Okay, so this is the Perseverance rover, and the main event of 2021 in the spring was the landing of lots and lots of rovers, well, two, on Mars, and that was really, really exciting. So this is actually a picture on Mars. But first, I'm going to come back to Cyprus. Now, Cyprus, of course, we observe Cyprus from space with Earth observation satellites, and Cyprus drew a lot of attention this year. You see here, this is a picture taken from the ISS by Thomas Pesquet. And Thomas has a history of taking pictures of Cyprus. He finds it very beautiful. Now, this is not in the winter. This is I think it was in October, on October the 1st, that he published this. And as you can see there, the white stuff is clouds, and some of the comments, I see George wrote a comment as well. This is an image I took a screenshot from Facebook, and lots of people are commenting, oh, there's a lot of clouds for Cyprus at this point in time. Now, more crucial than a very pretty picture was this. So in the summer, in July, on the 28th of July, there was huge forest fires in the Mediterranean. And this is an image that was built up from satellite data from NASA's NOAA by students at Tepak University, and they actually capture the smoke from the really significant forest fires that we had over the island. Also, for anyone who was living in Nicosia, it was actually quite frightening because there was a lot of smoke and smog, and no one knew if it was dust or not. But basically, there was even bigger forest fires in Turkey, and this smoke came over our island and really affected the visibility, the air quality, etc. And it's something really important for us to be able to monitor forest fires from space and monitor air patterns and maybe prevent such big fires occurring in the future. The other big event that happened in the summer, and again was tracked from space, was this. Okay, so here we have an oil slick, a huge oil slick that originated in Syria. And there was a lot of concern that it was going to spread and actually cover the eastern coast of the island. So cover like Ayanaba, Mohosas, all the eastern coasts of the island. And this was tracked very carefully with satellite imagery. The spread was tracked, and contingency plans were actually made by the ministry to gather up this slick if it was going to hit Cyprus. Luckily for us, it didn't. But I mean, it was well modeled, and so luckily for us, it didn't. And so another country had to deal with this slick coming towards them. And this is Earth observation from satellite, and satellite data really helps us predict and deal with natural disasters, among other things. Now, the next big thing that happened in 2021 was all about Mars. And I remember the day I saw this picture really, really vividly. It's amazing. So NASA launched a mission in 2020, 2020 Mars mission, and they plan to deploy a rover. This is the rover Perseverance that you see here on the surface of Mars in 2021. And it was an utmost success. And with that success came images like we've never seen before. The resolution, the quality was amazing. This is one just before the rover hits the surface of Mars, and you can see the surface of Mars in turmoil, being blown by the sky crane that was carrying the rover. It was a great success. And the second thing that was a great success was the helicopter. So as part of a technology project, a helicopter was designed to be flown on Mars. And again, it was really, really successful. I have a link to the video that shows this flight, but I'm not going to play it because we're limited in time today. And at the end, I'll put it in the chat so that you can click on it if you wish to see this. So the helicopter was an absolute success, and it was a technological feat that worked really, really well. And that can be used in the future for exploration and going places where a rover with its wheels can't go, for instance, cliff faces. So a helicopter flew on Mars in 2021. Not only did NASA go to Mars, but there were other countries as well. So the first Arab interplanetary mission was really, really successful. It reached Mars in February. So it was led by the Emirates, and the main objective was to map Mars weather. And so a small country managing this kind of mission successfully is a great, great, great feat in space exploration. Now, the third country that I'm going to talk about is China. Now, China's mission was launched on July 23rd, 2020, and it involved an orbiter and a rover. Now, many other countries have attempted to put a rover successfully on the surface of Mars, and the USA with NASA is the only country that had managed successfully to do this. And on the 22nd of May, China became the second ever nation to actually successfully deploy a rover on the surface of Mars. So that was a great success. Here is a selfie that was taken a few days later. So basically the rover you can see here is on the left and the lander is on the right. Now the rover, to take this picture, it deployed a wireless camera. So it drove a few meters forward, deposited a wireless camera, and then drove back to actually take the selfie. So here you have a selfie of China's rover and lander on the surface of Mars. Now, this is the lander, and you can see like there's prominent Chinese flags everywhere. And when the rover landed on the surface of Mars, it was being carried by this lander, and then it rolled down slowly onto the surface without mishap, fully functional. So a great success for 3 countries going to Mars this year. Now, the second thing I want to talk about is asteroids. So as you know, most of you probably know that at the planetarium, we hunt for asteroids, and we've had lots of successes in that area of astronomy. Now, there were 2 missions launched to go and investigate asteroids this year. One is called Lucy, and it's the first mission to go to the Trojan asteroids. This mission is going to take 12 years to get a lot of information about the Trojans, because the Trojans are orbiting next to Jupiter, basically. So they are a bunch of asteroids that we haven't studied in depth that are in front and behind of Jupiter in a special place orbiting around the sun. And this mission plans to visit several asteroids as well as the Trojans on its journey there. Now, the second one is called DART, and this was launched recently. And what it's going to do is it's going to test to see if it can move an asteroid in space. So this mission is going to an asteroid, and I wrote the name down, I've forgotten what it's called, Didymos. So it's like twins. It's a small asteroid with a smaller asteroid gravitationally bound to it. And DART is going to collide in 2022 with this asteroid to change its speed and path. And maybe that can form part of a defense mechanism if we ever see that one of these objects is going to come and maybe collide with the Earth. So that's really, really exciting. There's also an asteroid mission planned for 2022, launched in 2022, called Psyche, which is going to target a metallic asteroid and find out a lot about that. Now, the ISS is the very, very famous space station orbiting the Earth. People have been on that station for 21 years continuously. And this year marked the first year that a film crew went to the ISS to shoot a film called The Challenge. So in October 2021, an actor and director actually flew to the ISS and shot The Challenge. And my inside information tells me that not all went as planned, but they came back and they said it was very successful, and there were a few issues on the way, but we're looking forward to seeing that film shot on the ISS. 2021 also marks the beginning of the end of the ISS. So NASA has approved funding until the end of this decade. So in 2030, probably the ISS is going to start to be decommissioned. And in fact, there's lots of private companies that have won tenders and to actually participate in commercial low Earth orbiting space stations. So the shift is going away from this international cooperation to more commercial purposes, with private companies actually taking part in this. So one of these companies that has won a bid is this one that you see here. So that's the plans for the ISS in the near future. And a lot of the countries that are taking part of it are planning their own separate space stations. 2021 was also a big year for space tourism. So it's the year that space tourism took off. In the summer, we had Virgin Galactic suborbital flights. We had Blue Origin suborbital flights, and we also had Inspiration 4, which was a SpaceX tourism mission that actually put 4 people in space and orbited. They were orbiting the Earth for 3 days, and it's the first time any people have gone into space without an actual astronaut. So space tourism kicks off. It's still really, really expensive. I'm not sure I'll be able to ever afford it, but it was a big year for space tourism. Commercial space flights, you can pay to get go to space now pretty easily compared to what it used to be like. Now, the last thing in 2021 is an astronomer's very special Christmas present. So on the 25th of December, the James Webb Space Telescope was finally launched after many, many years of delays from the ESA launch site in French Guiana. And that is very exciting for astronomers. So it is a huge space telescope designed to observe basically as far back in time as possible, designed to observe the very origins of our universe. So we're going to try and look back into space, back in time, to observe the very origins of what happens. And it's really, really exciting project. At the moment, everything's going to plan. At the moment, these sun screens, so this area that you see at the bottom, this silver canopy, it's about the size of a tennis court. That is being unfurled slowly at the moment. So everything is going to plans, and fingers crossed, in a few months, we'll actually receive information that this telescope works successfully. Now, so they are the main highlights that I consider to be in 2021. It was a great year for exploration, an excellent year for exploration. 2022 is going to be a big focus on the moon. So there aren't going to be any humans setting foot on the moon in 2022, but we have a new space race. We have the Artemis missions from the USA, from NASA. We have India is going to attempt to land on the moon again. They were unsuccessful a few years ago, but they didn't give up, and they're planning to land again in the summer of next year, 2022. China also has a project that's ongoing, that's very successful, all about the moon. Russia is also sending a Luna 25 mission to the moon, and Japan as well. And in addition, again, you see the private sector rushing to do this as well. So there are 2 private American companies that are planning moon landers to be successfully deployed in 2022. So 2022 is all about the new moon race. Now, the moon race has these 3 objectives. We want to try and create a permanent presence on the moon, because it can be like a stepping stone to get us further and explore further in space. And also there's quite interesting mineralogy on the moon, and there are some resources that you don't actually find on Earth that commonly. So on the moon, there's a abundance of resources that are very difficult to find on the Earth. So that's my summary of 2021 and 2022. Any questions?
Thank you very much, Katie. Great summary. I have to add something. I think, if I remember well, in the end, 29th or 30th of April, China launched its own space station, Tiangong.
Yes, they did, yeah.
And the reason is that, since I read somewhere on internet that since the year 2011, they were banned from the International Space Station because the Congress voted that it was that they banned them because for security, for the United States security reasons. So they now created their own space station. So since I think the 29th of April, because I remember we celebrated the Global Astronomy.
Yeah, it's successful, very successful, that station.
When it's fully deployed, it's much smaller than the International Space Station related to its mass. I googled it now. It's 1/5 of the mass of the International Space Station at the moment, but they are growing.
Yeah, and they've completed successful spacewalks as well. So they had the first woman astronaut, Chinese astronaut, complete a spacewalk from there earlier this year.
Incredible. Yeah. Oh, great.
Thank you, Katie.
You're welcome.
Thank you very much. Let's proceed to our next guest speaker. It's his first presentation at our Science Cafe, and he will talk about International Olympiad of Astronomy and Astrophysics. Ara Mahdessian, welcome.
Thank you. I will share my screen.
Good evening, Ara. We are very proud of you. Just to let you know again, one more time in public, congratulations for your achievement.
Thank you. Okay, can you see my screen?
Almost. Yes, we see your screen, but not the presentation yet.
The presentation is on the left. Yes, drag it to the right.
Yeah, perfect.
Can you see? Okay. I am Ara Mahdessian, and I will talk about my experience in the 14th International Olympiad on Astronomy and Astrophysics, which was this year. And So the first thing is how to get chosen on the team and how to participate. So you have to do well in the National Olympiad. So you can sign in from the Enosi Physikon Kipru site. Here I have a picture. And you have to study by reading the book. It's in Greek because it's Cyprus. And we have the cover for the Greek book. You can also find it in the website. And also you can do past papers. I find that very useful. And because many of the questions are similar. And you need to go to the exam and do well. So you need to come in the first 5, I think, in the Liceo. Or I did well in the Gymnasio and I got in the team. And in Cyprus, it's only in Greek. So I made this graph, which shows the difficulty of the National Olympiad and the International Olympiad. So you can clearly see that the International Olympiad is much harder than the National Olympiad. And so how did we study? The team, the 5 of us, which I will say later who we are. We had some lessons with the team leaders, who are Vasilis Vasiliou and Yorgos Kellidis. And like we went to Amiandos for star observation. And also we had some lessons with Miss Hara, who is from Hollandia, I think, and the leader of the Greek team. And she helped us a lot. She gave us some exercises, and we learned about linear regression, which was very useful. And also I had lessons with Mr. Alexander, who is here in the meeting. And thank you for the help. And I'm still continuing my lessons with him. And I study on my own. This is the book that I used, the Fundamental Astronomy. And I didn't read all of it, but I'm reading it now. And there's also an IOA syllabus, which you can Google and you'll find everything you need to know. So the hotel that we stayed, normally we would travel to Colombia, which is the host, which hosted this year's IOA. But because of COVID-19, we stayed in Cyprus. We stayed in a good hotel. It's KITION Palace in Limassol. And you can see this nice staircase and the nice food. And we had 2 desserts every day. It was strange. So the team, I will tell one by one. So first, the team leaders, Vasilis and Yorgos. And then we have the hotel manager, who is for some reason in this picture. And that's me. And the chef, who became good friends with one of the supervisors. And we have Anastasia, who was the oldest one in the team. And she's in university now. And I think studying physics. Yorgos, who is also, I think, 3rd year in Liceo. And yes, he was my friend, and we played chess together. And Dimitris, I think we stayed in the same room. And Kyriakos, yes, and Kyriakos, and we studied together. And I like that he said he wanted silence when studying, and Yorgos always made a lot of noise when studying. And also the supervisors who aren't in this picture, they were Angelos and Rorula. So the first test was on Monday, the data analysis. So on Sunday, there was the opening ceremony, which there were some technical problems, but generally it was okay. And I'm going to define a procedure, a function, I will call it prep, such that prep of data analysis is equal to this blue box, which is eat lunch for 1 hour, study for data analysis by studying, eat dinner for 1 hour, then continue studying for some time, then discuss about maths or physics. Usually we would discuss until 12:30 the first few days, and then we would stay for longer and longer every night. And then we would sleep for some hours and then eat breakfast. I think breakfast is from 6 to 10, but we would usually just eat at 10 because we would sleep so late. And then study until the exam, which was always at 12 a.m. Cyprus time. And we did this every day. It was a program that we followed every day. Yes, so this exam happened from 12 to 15, so it was 3 hours, and there were 2 questions, and there were 2 very long questions. So I was planning to spend 1:30 and 1:30, but I ended up spending 3 hours on the first one, and I didn't have time for anything for the second one. So the first one was about the galaxies and their proportions of baryonic and dark matter. Baryonic is the normal matter we used to. And we were given many different formula, and we had to do things like linear regression, which is the method of least squares. And it was a very nice question, but I don't know anything about the second one. And you can see the formula for linear regression at the bottom. Oh, wait. For some reason, the presentation was closed.
Oh, well, take your time.
Wait. Okay, so the solar observation was on Tuesday. It was the second test. And we had to learn the program J-Helio viewer, which you can see at the bottom of this page. And what you do is you take pictures from many different observatories and you analyze them. For example, you find things like solar flares, and you can see the magnetic fields. And yes, you can see the distances from the sun. And we had to analyze for the exam, which was 2 hours, solar flares. There was one solar flare, and we had to calculate its distance as time passed, and using our computers. And we had to plot 3 graphs. One of them was distance time, then speed time, and things like that. And then we had to calculate the energy that a helium ion and an electron would have as they hit the Parker probe, which was at this distance. However, there were some technical issues. And the program stopped working because many people were using it at the same time. So we tried using the internet version, the online version, but that also didn't work. And during this time, we were discussing the questions. I don't know if this is legal, but still we were discussing the questions. But still we didn't know the answers. So after 2 hours, they sent us what we were supposed to do with the program, and we just answered the questions. Now the theory, which is the longest one. So we did prep of theory, which is the function I had defined earlier. Exactly the same things. And it was for 5 hours and had the most marks, I think 250 or something like that. And there were 15 questions. The first ones were easy, but as you kept going, it just kept getting harder and harder. So the first one was 4 marks, and it asks us to calculate the energy released during the collision of 2 black holes. And we were given their initial masses and the mass of the 2 new black holes. So what you have to do is just calculate the difference in mass and multiply it by c squared to get the energy. And these are some of the questions Another one, we had to find the distance of the two mountains in the IOA logo. And we were given their coordinates and heights about sea level. And we had to take into consideration the curvature of the Earth. I didn't solve it, but someone else said that we had to find their distance, ignoring their height above sea level, and then use trigonometry to find the distance. And the last one, which I didn't even attempt to solve, was 60 marks and about cosmic strings. Yes. So the team competition was on Thursday, and something we didn't study for the team competition. Instead, we studied for the planetarium, which was on Friday, because first we didn't care about the team competition and we didn't know what to study. So it was for 3 hours, and we were given hundreds of measurements of stars in the Perseus arm, which is one of the arms of the Milky Way. And we were given their galactic longitudes, the temperatures, and things like that. And when we need to use Excel to make a graph of the radial motion of the stars against the galactic longitudes, then we had to find a mathematical model for a formula for something, I don't remember. And then we had to repeat it for the outer arm and get some results. So Kyriakos was the one working on Excel, and I think he was the only one who knew how to use Excel. I did some of the calculations, and I found the mathematical formula, even though it was probably wrong. And Yorgos was explaining Dimitris, Anastasia, and me about the radial and proper motions of stars. And he helped us understand the question very well. And wait. Okay, so the planetarium was the one on Friday. And since it was the last one, we were determined to study a lot for it. So like Dimitris stayed up until 3-4 a.m. studying. And we had to learn everything in the sky, that is stars, constellations, all the Messier objects, like there are 110 of them. But because we were studying the last minute, we failed to learn everything. You can see here on this map something that Kyriakos made for us to study. Is a very useful map of the Messier objects. And we studied using Stellarium, which is a very useful application. And the test was from 12 to 12:45, but we didn't have a lot of time to answer everything. And even though it wasn't a lot of marks, it was easy to lose marks. It was a multiple choice question. There are many multiple choice questions, but they were very hard. And the supervisors were showing us a PowerPoint with the questions, and they were just playing the PowerPoint, and we had a set time to answer each question. And then they didn't wait for us to finish. So here's one of the questions. So who's that Messier object? Oh, that is M47, not to scale. You need to see that the bright star up there is Sirius, and then you see that's the constellation, the dog constellation, and you had to know this stuff. So on Saturday, after the exams finished, there was the cultural day, and all the countries had to show a video of their culture. But since this was online, and there wasn't a lot of organization, and very few countries showed something. And while we were waiting, Colombia presented their video 2 or 3 times, and they were asking, "Do you want to see it one more?" And we were saying yes. And what we did in Cyprus, we just copied last year's video, which was probably a video from the internet. and Dimitris just put IOA 2021 at the end. And we presented that and said it was original. And after 2 hours, some of the other teams started discussing the questions, especially question 15 with in the theory. And they were saying, "Did you solve this?" And we didn't know what was going on. but they also didn't know because what you'll see is the questions. The actually last question was very hard, and the team leaders were saying that there was a war whether to put this question in or not, because there was something about integration. Even though they put the formula for integration, it isn't in the syllabus, so they were reluctant to put that question. And so the closing ceremony was held on Sunday, and it started very late because they decided to give out a few more medals because their marking was strict and the test was hard. But I got an honorable mention, and that's great. I don't know if I expected it. In conclusion, I enjoyed the Olympiad a lot. It was very fun studying astronomy and astrophysics, and I'd made many friends like Dimitris, Yorgos, Kyriakos, Anastasia. Everyone was there. We were friends with everyone. I would like to go again next year, which will be in Ukraine, and maybe get a medal. And I would recommend it to others who like astronomy and would like to do this. Thanks for watching.
Wow.
Thank you.
Excellent, excellent, excellent. Congratulations, Ara. It's not something easy to get an honorable mention anyway. And from what you show us, we can understand that it was not a straightforward exam. It was a tricky exam, and of course you had to read everything, and
Yes.
you need to remember everything. Even we used it professionally since 2008, and I can go out for a few times, and I can forget a few things. Even if I know them, maybe that day I can forget them. And we have experienced this with at the International Astrophysics Conference. Alexander, maybe you remember this. Remember when we had the world's greatest astrophysicists that they used Hubble telescope, they came from Atacama Desert, and when they looked at the sky and the eclipses, some of them they couldn't even recognize the constellations. It was really a shock for me, but you know, they're theoretical, they use computers all the time, they have everything ready, they analyze them, so it could happen. But I'm really impressed that they gave you the last question with 60 marks, and you said you didn't touch it and you got an honorable mention. This means that most of them didn't touch this question, and they should have been. I'm really wondering, what did they ask about cosmic strings?
I don't know, because I read the first two sentences and I just left it.
Okay.
Actually, no
It
worry.
looks scary.
I just know that there was something to do with integration, because the team leaders were saying it on the last day that they didn't want it to be put on the exam. Something like that.
Anyway, Ara, you shouldn't be very disappointed because of my
He shouldn't be
thesis.
disappointed at all. He should be proud, as we are proud of him, and he did perfect.
Because of my scientific research was in cosmic strings. So most probably we may settle with this task one day. I'll put it in curriculum of KITION Astronomy Academy and we'll dedicate a lesson to it. Yes. Okay, thank you very much, Aaron. It was really impressive to know what's going on, what's the level of International Olympiad, and I wish you good luck in next year.
And
thank you.
And I want to point out something that my friend Ara pointed out here. In relation to not only the difficulty, but we had the Stihia Astronomias και Astrophysics, which is a Greek book, and we have it here at the planetarium. And they use one of the books he used. I used it at the university with the other book called The Universe, Astronomy Fundamentals, and the universe that we use for the astronomy course at the university. But also, the most important thing is that the astronomy Olympiad in Cyprus given only in Greek language. This is not fair for students. First of all, even you have a very good student who does well in Cyprus with the Greek, and he doesn't know English, it's not fair for him to be, I don't want to say the word humiliated, but to face difficulty with English in the international astronomical, in the international Olympiad. But it's also not fair because many schools from the private sector in Cyprus, like English School, American Academy, they participate, and all the curriculum is in English. And they have to face this difficulty in translating everything to Greek or to extra lessons to learn everything in Greek. And I think this is not really fair for the students. I think that the exam should be given in the Olympiad in Cyprus for at least English and Greek. So we mentioned this to the appropriate people before, and we posted somebody. KD, what was the sky that he attended our event last time, and we mentioned it. He was in the ministry, I remember. Yes. Yes.
We're working on it because it's also the physics Olympiad.
Yes, it's the same for the physics Olympiad.
But it's not for biology, chemistry, and maths. They have it in English and Turkish as well.
Mm-hmm.
Okay, so let's proceed further. We have one more special guest, and Joe Chamba introduced that our guest to us just few. We may count even hours, Joe, correct? How many hours ago? So just recently, Joe showed us a beautiful picture of Comet Leonard, which was taken by our next guest speaker. Just not to confuse, this image on my picture is made from another guy, Chris Shure. He is in Arizona, so it's different. Well, anyway, I wanna, because of many Science Cafe here connected with astrophotography, I wanted to introduce Maroun Habib, our new guest from Lebanon, with his talk about Comet Leonard.
Hello, everyone. Can you hear me?
Yes.
Okay,
yes.
That's perfect. Yes, first of all, I would like to thank you for having me. Thank you, Alexander and KITION Observatory. So I will be talking about Comet astrophotography today. Excuse me, I will not get and dig into the science that you were guys talking about. So I will be talking from an amateur perspective, and that's it. So first, I'm gonna proceed by sharing my screen. Let's see. Can you share? Can you see my screen now?
Yes.
Yes.
Okay. So just introducing myself, my name is Maroun Habib. I'm an astrophotographer. I usually practice astrophotography in Lebanon, but since before the pandemic, I used to travel the world. For example, I've been to Chile, I've been to Iceland, to Norway. So it's like I was practicing my hobby wherever I go. And my daily job is actually, I'm a cybersecurity director for a company based in Lebanon. I'm also finalizing now my master's in astrophysics also in Lebanon. So what I like to do the most while doing my astrophotography, it's not only about the beautiful pictures, if you may think so, but I also try to share the science knowledge or the science information from the photos. So most of the time my photos come with a scientific description that might dilute, let's say, if we talk from a public part, so most of the time science, let's say, is known to be boring. So it's like I try to dilute science and show it in a better way. So some kind of under the field of science communicator. Of course, I'm not claiming that science in general is boring, but it's like many people might think so. So I'm gonna proceed, and this presentation, by the way, is supposed to be interactive. So whenever you've got questions, please do not hesitate to interrupt me, and I'm ready to answer them whenever you know. whenever you want. So comets in general are dirty ice balls. They are made of rock, they are made of gas, of ice, frozen ice and frozen gases and all the stuff. The main difference between comets and asteroids, whenever from afar, they are most of the time observed to be the same, because whenever they are far, it's kind of impossible to differentiate between them. It's whenever they get closer to the sun and when that ice becomes ionized and it becomes and the ice starts melting, it start creating some kind of tail. So most of the time we see one tail or two tails depending on the composition and how close they are to the sun. So most of the time comets are unpredictable, so disregarding how much we know about comets, so every now and then we think that the new comet is gonna become the new Habib and stuff, but most of the time they either disintegrate, they even will not be up to the expectations of amateurs and scientists. So it's still some kind of a gray area, and they are still developing more knowledge about it. And whenever they approach Earth and start developing the tails, so things might become more sexy and more interesting and more, sometimes they might become visible with the naked eye, just like in 2020 and June and July 2020, when the comet Neo was. So in the past, comet hunters used to be those people who discover the comets. So, but nowadays that we've got lots of observatories to detect the NEOs, the near Earth objects. So in order to see if there's an asteroid hitting Earth and stuff, all those things we see in the movies, amateur astronomers' contribution to discovering comets has been relatively reduced, with one exception regarding the Leonard that we are currently seeing, and mainly at the borders of the northern hemisphere, which can be also be seen from Cyprus, but it will be mainly more prominent in the southern hemisphere when we say Chile, South Africa, and Australia and all the other stuff. So I will proceed by sharing some photos, but first of all, I'm going to share some information about the if anybody of you is interested in taking of comets. So it can start as simple as having a camera, a lens, and tripod, and intervalometer. So it can be simply as this, and the more stuff you might need some dark skies or away from light pollution and all the lights that might be emitted from the ground, let's say artificial lights. Things can get slightly more complicated if you are using a tracker. I'm going to share my tracker here in this photo. A tracker is a device that we all know that the Earth rotates around its axis. So that's why we see the sun and the moon that are rising from the east and setting from the west. But the same happens to the stars, and everything in the sky, astronomically speaking, they are moving. So the tracker that I'm showing in this picture, and I just show, is actually reverses the rotation of the ground. So that's why, in order to take longer exposures and to get more details from the comets or the astronomical objects we are taking photos of, a tracker is needed to get those extra details. And in case you want to take things more complicated, which is not something we want to get into this time, it will be about using a heavy equatorial mount with large telescope in order to get more details and deeper images of the comets or the astronomical objects we are taking. So we were just talking about deep sky astrophotography, let's say, when it comes about comets. The main problem in the I'm going to call it the main challenge in taking photos of the comets, and whenever they get closer to the sun, which relatively speaking, they get closer to Earth, they become faster due to the ellipsoid rotation. So they become faster whenever they spin around or they make the leap around the sun and Earth. So that's why if you are taking long exposure, let's say up to 5 minutes, the comet is going to appear fuzzy. So that's why we need to take shorter exposure than, relatively speaking, to what we usually take in order to get those details. So in order to, I'm going to try to finish the technical part in a very fast way. So in order to process or to get around this challenge we were talking about, we take shorter exposures and we stack the comet, we separate the comet alone, we're doing the processing, and we separate the stars alone or the background sky. And later on, we merge them and some kind of digitally merge them in order to get the details out of it. So I'm going to first start by the comet Leonardo, which was discovered by an amateur astronomer earlier this year of 2021. And we're going to see lots of other comets, which the majority actually happened in December. So it's like every year we call it the Christmas comet and stuff, but it has nothing to do with Christmas in general or any of those celebrations we do. This picture was taken 2 days ago above Lebanon. You might notice something that there are a lot of light pollution that is coming from the ground, but at the same time, the comet was relatively bright. That's why it was appearing above all this civilization of light pollution and all this artificial light originating from the ground. Of course, it would have appeared more vivid and more details with a green head, but since it is very low at the horizon, it does not rise more than 10 degrees. So whenever the sun sets, so it slightly starts declining into disappearing behind the horizon. And we need to add to this that whenever you are observing towards the horizon, the atmosphere is very thick and we will be receiving less photons. And because all the light originating from the comet will be absorbed by the horizon. That's why it's usually challenging in taking photos of astronomical objects when they are around the horizon. I'm going to start sharing some other photos of comets. I'm going to start my first comet. I took a picture of, it was in August 2018. It's Jacobian Zinner, and it was my first experience with a comet. So I took the first exposure and suddenly I saw the comet that is just, it was a line. So it's like all the stars were dots, but the comet was line. And that was the first time I realized that no, actually comets are very fast and we should take faster exposure. So at the beginning, I was taking 5 minutes, the regular 5 minutes with the telescope, but later on I reduced it into 1 minute so that it doesn't trail. So I took several photos of this comet and I stacked them. I did the separation I just mentioned in order to do it. And luckily, I was very happy that my first experience with the comet was actually featured on NASA Astronomy Picture of the Day. So all those photos that I have collected, I merged them into one time lapse or a stop motion. And in this video, which I cannot play now within this Zoom application, so it's like you will see the comet that is moving next to the star cluster. So I named it back then salt, pepper, and ice because that cluster is actually named salt, pepper, and the comet represents the ice. And obviously the people of APOD, they like food. So I do believe that they picked this comet not because of the image is beautiful, but actually because they like salt, pepper, and ice. So that's another picture of the comet next to the Heart and Soul Nebula. I took it with a tracker. This one was taken with a tracker, small equatorial mount, the one that I just showed you at the beginning. And that was also another picture. Another comet, it was a comet Pan-STARRS. At the beginning, if you remember that I mentioned there are some observatories that detect the news. So Pan-STARRS is one of those observatories, if I'm not mistaken, it is in Hawaii. And it was one of those observatories that detected the Pan-STARRS. Pan-STARRS is actually, you can see this green bulge on top of it. I took this image from my roof. I have a small observatory also. And that's another comet where Tannen, it was taken actually with a tripod, with a very simple, just a tripod, a camera, and the lens. We just went to dark skies, and you can see this green patch next to the Pleiades in here. Another shot, and now we're actually back to the creme de la creme of the comets that happened during the last 20 years. It was the best that happened since Hale-Bopp, since 1996, 1997. Hale-Bopp was actually very clearly visible with the naked eye. It's like you look at the comet, you see it, and you can see the tails, even if you are actually looking at it from slightly light polluted area. So this is Comet Neowise. This was taken with a tracker, a telephoto lens, and a camera, regular camera, not even astronomy modified camera. And that was, this picture actually might appear that it was taken with a regular lens, but actually I took it with a telescope and an equatorial mount. So I was also lucky that whenever this comet was discovered, I directly went into taking a photo, and I was also lucky to be featured on NASA Astronomy Picture of the Day. So it's like 2 out of 3 of my NASA Astronomy Picture of the Day features were actually comets, and that's it. That's another picture of the comet Neowise. It was also taken from the mountains of Lebanon. It's like comet Neowise was the most chased comet by myself. It's like every day I was finishing my work and just going to the fields and chasing this comet, and it was some kind of, I had a relationship with this comet because I chased it all over Lebanon, from the north to the south, from dark skies, even from light polluted areas. And it was a great experience, actually. And I really wish that we can see more comets from time to time, because during the last 10 years, we haven't had those great comets, let's say, if we compare to Neowise or to Leonardo, which is currently happening. But yeah, they kind of bring some excitement comparing to the regular deep sky objects that we are used to. So whenever there's a comet, there's something interesting in the sky, and there's some kind of dynamic and excitement in order to photograph them. So that was my very short presentation. Actually, I blame Alexander for being short because he just told me about it at 7:30 p.m. So I really hope you enjoyed it, and please do ask questions. I guess it would be the best part of this presentation by asking the questions and me answering.
Okay, let's ask questions.
Maroun, it's a great honor to have you here with us.
Thank you, George.
Really interesting pictures, and I always wanted all of my photos to be astropod in the iPod.
Yeah. It was totally unexpected. Yeah, it's a great reward, by the way.
It is a great reward. Yes. So congratulations.
Thank you.
Very beautiful images, and I don't believe that it's only because of salt and pepper, but also because of the very beautiful image, very high quality work done, and our science center here is always open for you. We would like to have you for another complete Science Cafe, not to share the time with others, but please prepare for a complete presentation. So I'm throwing the ball back to you, and you may even on the next one, because we haven't planned anything for January yet. So 3rd week of January, you are welcome.
Yes. Thank you. It would be a pleasure. And actually, it's up to Alexander to tell me more than 30 minutes before the talk, and I will be totally ready for it.
Actually, it was planned for last week, and because of that busy schedule and because of the COVID measures and some heavy work, and we are preparing also for the Pan-STARRS campaign. It starts on the 30th of December, so we have to gather the team, etc. So yes, we are working with Pan-STARRS in Hawaii, in Hagelela, both telescopes. So
okay, so one more question.
Yes.
And you're
always welcome here to.
Do you have questions?
Yeah, what camera did you use?
Okay, I mainly use let's call it my working horse camera as a Canon 6D, which is astronomy modified. So what happens is that what do we mean by astronomy modified? So it's gonna take time to answer this question, but I'm gonna make it fast. Originally, all cameras are made to mimic the film camera and to mimic the colors. But since it's very hard to create a chip that is 100% similar to it, so they create a camera chip or a sensor that is sensitive to ultraviolet and to infrared. So they create this sensor, which is easier to make, and they put some extra filters. The first filter actually removes the ultraviolet, the other removes the infrared, and an extra filter to calibrate the color to become very easily visible to the human perception, which is mimics. So what happens in here that it blocks the hydrogen alpha spectrum, which is at 656.28 nanometer. It blocks around 75% of it. So, and since most of the astronomical objects in astrophotography are rich in H alpha, actually the universe is mostly rich in hydrogen in general. So what happens in here, I remove one of those filters that is actually blocking the H alpha, so it becomes more sensitive. So I use a 6D, it's an old camera, but I actually have 360 cameras that are modified. And the tests have been shows that the old 6D is better than the new 6D when it comes to astrophotography and when it comes to low light dealing with noise. So this is how, this is the main camera that I use for my landscape. So I'm mainly into deep sky astrophotography, I'm into landscape, but my favorite field, and that when things are in the middle. So taking deep sky object with the ground, this is my favorite part.
Thank you.
Thank you.
Thank you. Okay, let's proceed further because of we are very close to our next talk, and it is observations of astronomical phenomena. I wanted to present Jim Wiggins. With him, I met first time in 2006 when we observed total solar eclipse. It was in Egypt, and now Jim is here, telling us our future. Welcome, Jim.
Hi, everybody. Thank you. I have just a question. Do you think we have time for?
We should listen to you.
Yes, yes.
Because I'm happy to move it to next cafe if you want, but
we have a lot of time.
Okay, fine. Let's do it. Okay. Well, hi, everybody. I guess you can hear me. Yes. And let me see. This is actually probably my first time sharing a screen on Zoom, and also my first time, I think, even making a PowerPoint style presentation. So this will be fun. And my at first the plan was for me to talk about my observations during 2021, and I have to admit, I've been a very, very bad astronomer this year for various reasons, including that they hung Christmas lights next to my observation deck last week, and I was traveling in the summertime and so on. So what I'd like to do is just actually talk about future, if that's all right with everybody. And this would be a situation where we can use the skills that we learn about astrophotography, for example. Now, is my screen sharing properly here? Or are you seeing?
We see preparation for presentation, not itself.
Let me ask my assistant if I have an assistant.
Could it be to press play, maybe?
Oh yeah, that would make sense. There we go. Okay, here's my beautiful first slide. What I wanted to talk about is the next 4 total eclipses that we have coming up in the next few years that are actually full total eclipses, and some of the techniques for planning for those. So this is looking ahead into the future a bit. Let's see. Now, how do I get to the next slide? Oh, like that. First of all, I'd like to share some of the total eclipse planning websites that I use. The first one is sort of the granddaddy of them all. The official NASA Eclipse website, basically put together by Fred Espenak, who did most of the calculations that all sorts of different websites use for figuring out where the moon's shadow is going to reach the Earth and where you should go to stand to watch an eclipse and photograph it. Oops. Let me just take that same list there and paste it into the chat if I can. I'll do that after the presentation. So the next four that are the most interesting, I think, if you disregard annular eclipses, where you don't actually get totality, you get you still have a bright sun, so you don't get to see the corona of the sun. The next four that are reasonable to view are these. There's one in 2023. That's about a year and 4 months from now. There's one in 2024. There's nothing in 25, but there's again one in 26 and one in 27. Both of the first two are in April and the second two are in August, interestingly. The 2023 eclipse, the very next one, however, is pretty remote. So if you're going to try and go and see that one, it's going to be, well, first of all, we all hope that COVID has stopped messing up all our plans by then. But also, really, there's two places to see this eclipse. One is Australia and one is Indonesia. And in general, when you go to see an eclipse, if you look at this path of totality here, near the center, you'll see a little green square. It's a little bit hard to see probably, but it's has the letters GD in there, and that means greatest duration. And that basically is kind of where you'd like to aim for in general, because you'd like to see the longest eclipse that you can possibly get. However, there's a second very important aspect to worry about, and that is cloud cover. And so on another one of the websites that I put on the list that I'll add to the chat later, we have predicted cloud cover. And you can see that that's, whoops. Well, this is kind of the same thing. Basically, along the eclipse track, there's a big dip in the middle, and that means low % cloud cover. Those are good places to watch an eclipse. As the eclipse moves off to the right, the cloud cover increases again. You get to that point of greatest eclipse that you can see there, but now you're in a place where your chances are 50-50 of actually even seeing the eclipse. So looking at that data, my personal decision would be to try and go to Australia to see the eclipse. It's also possibly easier to get into Australia than into East Timor. I'm not really sure. Australia has better developed infrastructure for getting around. Roads are probably better. There's probably, well, I'm not sure if it's easier to find places to stay, places to eat, all that sort of thing, but it is a pretty remote part of Australia. Anyway, let's have a look. This is where it crosses Australia. It just barely crosses this little peninsula near a city called Exmouth. It also crosses an island, but as I've looked at that island, I don't think there's an easy way to get there, and there's really nothing on the island except oil drilling stations. So let's look at the area near Exmouth. Using Google Earth satellite view, or just Google Maps satellite view, gives an idea of what the terrain looks like. There aren't a lot of roads, but there is a road right about where you see the red line, which is the center line of the eclipse, crossing that white stripe, which is just not a particularly interesting marker, but where that road is would be an easy place to get to. So if we look at that particular spot, clicking on one of the maps on one of the Google Maps enabled websites, we can see the conditions of the eclipse, the predictions by Fred Espenak, and we see that the duration of totality is only 1 minute. So that's a bit of a tough one. That's a long way to go to watch a 1 minute eclipse, but the one thing about this eclipse that's interesting is it's what's called a hybrid eclipse, which means part of the eclipse track has totality and part of it doesn't. And the reason is because the moon is so far away from the Earth at this point that it's nearly exactly the same size in the sky as the sun. You can see that in the magnitude there of 1.006. It's just a tiny bit bigger than the sun. So what could actually be interesting about this eclipse is that one of the effects you get, which is called Bailey's beads, just as the sun is disappearing, could possibly happen more or less around the entire disk of the sun, nearly the whole, maybe half of the disk of the sun. It's possible, which would be really amazing. Normally you see maybe one Bailey's bead just as the moon is finally covering the sun. But because it's so much the same size as the sun, it could be quite interesting to look at. So then again, on Google Street View, we can actually drop in to that location and have a look. What is there? Well, there's nothing there. But you can see that the horizons are pretty clear. Nothing's going to get in the way of your observation. The sun should be pretty high in altitude. I think I forgot to look at what it was, but I think it should be quite high in the sky. And so basically to get to this spot, you'd have to probably hire a car and, you know, get a group of people maybe together to go there. And you might be able to camp out. I don't know. I'm not seeing any hotels, but I think in Exmouth, there's probably things available. One thing that I did notice was there is actually a brewery at this place, just near the center line of the eclipse. Crazy. So there is civilization around there. The following year in April, again, 2024, we've got another eclipse. This time it's crossing Mexico and the United States and a little teeny bit of Canada. Greatest eclipse location, greatest duration is down in Mexico. And if you look at the weather conditions predicted, and you look over to the left side, down in the lower left corner, blue color means good, probably clear skies. So in this case, probably Mexico is the best place to go. In fact, you can go right. Okay, here's again the cloud cover moving. The eclipse will move from left to right, going across Mazatlan in Mexico at the coast, across Durango, which is inland a bit. There's a place called Torreon, which is actually a pretty big city. It's about 750,000 people. And then from there, the eclipse moves into places with more cloud cover expected. This is the area near the greatest eclipse, greatest duration points. And you can see the city of Torreon there. Mazatlan is a resort city that's quite popular. Also on the coast would be another good location to view this one. If we look down into what the satellite sees there, again, we have pretty dry country. You're not going to be worried about trees blocking your view. And this eclipse has a much longer duration, 4.5 minutes. So that's a good one. That's quite, gives you quite a bit of time to do a lot of photography and other observations during the eclipse. This is the landscape according to Google Street View. Google has been here as well. I mean, Google's driven everywhere in the world pretty much, as far as I can tell. So this is quite interesting. This is a bit more interesting than the one in Australia the year before, because one thing that we've noticed in watching eclipses is that if you have some hills and mountains on the horizon, you can sometimes you'll be able to see that the shadow moves across them differently to how it moves across where you're standing. And that can be quite striking, actually. If you get a mountain, say, off in the distance, that's in the sunlight, while everything else in the foreground is dark, it can look pretty cool. And there are a few restaurants around that area, nothing too big and fancy, but it looks like the people are friendly. So might be a good place to go and check out. Third eclipse, after a gap in 2025, we get 2 August eclipses. And this one here in 2026 is coming down across Greenland and Iceland, and then across just ocean and landing right here in Spain, where I'm at. Lucky me. The cloud conditions for this one are really bad. Well, Greenland is okay, but Iceland is really bad. And then you get down to Spain and the cloud conditions are great. Blue is what you're looking for on these maps. This is the sweep across Spain. Just cuts right across the country. Recently, I myself did a long hike across Spain. It's called the Camino de Santiago. It starts in France, and I walked all the way over to the Atlantic coast. Here's the path that I took. So I actually cut across where the eclipse is going to come. And when I reached the place where the center line crosses this Camino, I found that, well, it's not a terribly long eclipse again. It's 1 3/4 minutes, nearly 2 minutes long, so that's okay. But what's great is there is an amazing castle right there, right on the center line. It's not in use anymore, as you can see. It's a bit destroyed, but the area around there is just beautiful. From the castle, you have an amazing view far off into the distance. I took these pictures myself. So you're going to get some really interesting effects where you see the shadow around you, but the far off mountains are not in the shadow, or they come in and out of the shadow at different times. And some of the local people are pretty friendly as well. And this fellow, in fact, I told him, I'm coming in 5 years to watch an eclipse here. And he said, okay. And I said, you will have everything ready for us, right? And my group of friends. And he said, okay. And we signed a contract. And he probably thought I was some crazy guy, but hopefully he'll remember me when I get back there. Finally, there's a most incredible eclipse in 2027, also in August. This cuts right through Northern Africa and the Saudi Arabian Peninsula. The cloud cover is great pretty much the whole way across the whole track of this eclipse. So you have loads of places that you can go to watch it. The place near the greatest eclipse is Egypt. And this is just near, well, that's the same country where, as Alexander said, we met in 2006. We met up near the upper left corner of Egypt there. And this eclipse almost crosses that same place, but not quite, just not quite. However, as you can see, the greatest eclipse point and the greatest duration points are down near the Nile River, near the famous city of Luxor. And there's, this was back in 2006. Who is that kid? So we were practicing our Arabic script there by poking holes in a piece of paper and projecting the crescent sun images onto a piece of paper. And that was quite a great experience, 2006. This next eclipse will be a whopping 6 minutes 23 seconds, almost 6.5 minutes. I mean, you can go out and, you know, buy something at the store and come back and it'll still be going. It's incredible. And it right here over the amazing city of Luxor, basically, it's almost exactly over Luxor, where you have quite interesting things to see. I mean, this is definitely an eclipse to plan for, I think. And it's far enough in the future that, you know, hopefully everything will be possible again and everyone can save up some money and get to this place. It's not even that far away. There's only one problem though. I have a hunch that the ancient Egyptians knew that this eclipse was coming and knew that the center, the greatest eclipse, was directly over Luxor, and they probably set up one of those rocks with a crack in it that's going to, you know, the sun will shine right through that crack just at the moment of eclipse, and it's going to release the zombie terror from the ancient tombs there. So I'm a bit afraid of this eclipse, but anyway, and the other thing is, I don't think there's going to be any kind of beer and wine available on this eclipse, even though the sign says maybe far away down this road you can find something. So anyway, that's some of the eclipses. The eclipses to come. And let me paste those links to you now.
Excellent presentation. Now you open up a window in our mind in our thoughts, to start dreaming of traveling.
Something to start dreaming and planning for. Yes.
Planning, especially 2027 in Spain.
26 in Spain and 27 in Egypt. Yeah, both of those will be fantastic. Yes.
Thank you. Some questions to Jim. We have time for one question.
Anyone got a question?
Okay, thank you, Jim, for this nice presentation. Now we know what to do next. And the nearest future is about meteor showers. We have quadrantids just in a week, and it's regular, it's okay. But that's what specific astronomers expect is the repeating of an outburst of Eclipse, which happened already, which was registered in 2015, and since that time no one observed it again, like outbursts. There were some, but not outburst. Outburst means 15 per hour at the time, but it was just during 1 hour or so. So on the 10th of January, you may mark this date, from Cancer constellation, we expect up to 15 meteors, and the moon just set 2 hours before the maximum. So it's good way to spend your night just before, on Monday morning, in fact, just before most of people are going to school or to work. So that's what's going on with meteors. And our next Science Cafe, I don't know whether George wanted to announce it now. Anyway, I know the date, the 25th of January.
As in the 25th of January, we are waiting for an answer from somebody. It's a surprise, but I believe he's so busy. So maybe we can invite Maroun to do the 25th, and we can postpone the next one in February. So, Maroun?
Yes.
Well, are you willing to do the 25th of January, and we postpone our other guest in February? Think about it and let us know.
Okay.
Perfect.
Perfect. Okay.
Okay. So no, the topic we will announce. We found the guest speaker, and we will announce the topic a bit later. So, well, and we are on the for the next year. That's why you may find your own language from this slide.
We even wrote it in Lebanese in Arabic for our Lebanese friend. Guys, I wish you all the best. Me and our team, we are wishing you all the best for the new year. Above all, health. May your life be filled with health, love, joy, and happiness. And lots of orbits around the star, around our star, the sun. Many years to live happily and enjoy our friendship and our knowledge in real life and virtually here through our online science cafe. We are always open for everyone to give you the stage and present to us. Thank you for being with us again, great honor, and hope to see you again soon. Happy New Year.
Happy New Year.